Hey guys, today we are going to start talking about how we have organized data and how we present that. Specifically, we're going to talk about a normal distribution. So the normal distribution is symmetrical. It's a symmetrical distribution in which the mean, median, and mode are all the same, or close to the same. So we don't have any outliers in a normal distribution, and everything is right where it's supposed to be. The standard deviation is a measure of how far values are from the mean. So it's a measure of how far values are from the mean. So is it above the mean? Is it below the mean? And how far? So what we do is we have a standard normal distribution in which mu is the mean. So this is the mean. The mean is 0, right down the center, right here. And sigma is the standard deviation. The standard deviation is 1. The distribution is standardized by the z-score. So that means that rather than having normal numbers down here, we always start with our mean in the middle. And as we go up from the mean, we increase by a certain amount each time. And on a normal curve, we're going to give those amounts just a 1, a 2, or a 3. And if they're under the mean, we give them a -1, a -2, or a -3. So the z-score really just shows us how many standard deviations a data value is from the mean. So the z-score is the 1, 2, or 3. The standard deviation is kind of what we're counting by. So we'll get to some specific examples in just a second. When the z-score is positive, the value is above the mean. When it's negative, it's below the mean. When it's equal to 0, the data value is equal to the mean. So there's a formula that you can use to calculate z-score. It's z equals x, which is the data value you're talking about, minus mu, which is the mean, divided by sigma, which is the standard deviation. So let's look at a couple examples here. A radar detector records the speeds of a group of cars that pass by. If the mean is 46, so that is our mu is 46. The standard deviation is 2.8, so that's our sigma, 2.8. Find the z-scores for each data value. So in this case, x is going to be 52. That's the data value we're talking about. So the z-score is 52 minus 46 divided by 2.8. And we just put that in our calculator, and we're going to get 2.14. And we generally keep these to 2 decimal points because later on we're going to use a table to look up these values, and 2 decimal points is where we want to be. So if we're going to do 42, that means x equals 42. And the rest of our data points stay the same. So mu is still 46 and sigma is still 2.8. So our z-score equals 42 minus 46, and you'll notice that's going to give us a negative number, which is good because that means that it's on the left of the normal curve, divided by 2.8. And when we put that in the calculator, we're going to get negative 1.43. So what that means is on our normal curve here, ooh, I can't draw, by the way, we have our mean in the middle, and then we have 1, 2, 3 lines on this side, and 1, 2, 3 lines on this side. Negative 1.3 or 1.43, here's negative 1 is next to the mean, and negative 2 is here, so negative 1.3 is somewhere in the middle. 2.14 means I started at the mean, which is in the middle here, and then I went up 1, 2, and a little bit past that, so 2.14 is over there. Lastly, we've got 47, so we're going to do x is 47, our mu is still 46, and the z is 2.8. So we're going to do 47 minus 46, so our number is going to be positive again, divided by 2.8, and our z-score this time is going to be 0.36. That means I'm just barely to the right of the mean. So let's look at labeling a normal distribution curve. So a normal distribution curve, we just said, is it's what you call a bell-shaped curve. The mean is right in the middle, and then you have 3 lines to the right and 3 lines to the left. And each one of those lines represents one standard deviation. So if our mean is 500, blow this up a little. Our mean is 500 and our standard deviation is 100. That means I'm counting up by 100. So this is going to be 600, 700, and 800. And then to go the opposite direction, I'm going to subtract 100 each time. And I label my distribution like that. Okay? So that is going to be how you would label a normal curve. You start with the mean in the middle, and then you go up or down based on the standard deviation. So how many standard deviations away from the mean is a score of 300? So here's our 300. So we went 1, 2. So it is negative 2 standard deviations away, because it's to the left 2. If a student scored 400 or 700 on the SAT, what is her z-score? So if I start in the middle, I go up, this is 1, z is 1 here. I go up 1 more, and z is 2 here. So z is equal to 2. And let's just say 2.0. So that's how you do z-score and how you would label a normal distribution curve. Now, you can approximate how much or where a data point is in relation to the rest of the data, or approximately how much data is within a specific range if we use what's called the empirical rule. So the empirical rule says that approximately 68% of the data, if you were to take fair and equal data, approximately 68% of it would be within one standard deviation. So that can be one standard deviation above or one standard deviation below. And you'll notice that what we've done is we've broken this in half. So 34% of the data is here below, and then 34% is above. But if you add those together, you get 68%. So 68% is within one standard deviation of the mean. The next thing is approximately 95% of the data is within 2 standard deviations. So that's another 13.5% on both sides. So 13.5 plus 13.5 is what, 27? So I have my 68 here. And then I add another 27%, and I get 95% total. So 95% of the data is within 2 standard deviations of the mean. So it's under that part of the curve. And then finally, we have 99.7% of the data is within 3 standard deviations. So that is this whole thing right through here. So 99.7 leaves 0.3 left. So I have 0.15 here and 0.15 here. When you add them together, you get 0.3. So that's the rest of your data. So that's 100% of your data and where it falls, assuming that you have a non-biased data gathering procedure. Okay, so how do we use this? So we look at the weights of 50 football players are normally distributed with a mean of 178 pounds. So that means the 178 goes in the middle. And a standard deviation of 8. So I add 8 as I go to the right. So that's going to give me 186. And then 8 more is 194. And 8 more is 202. And then I subtract 8 going the other direction. So 170, 162, and 154. Okay, so the question is, what is the Z-score for a player that weighs 158? Now you'll see I don't have a spot for 158 on here, or it's not labeled, so it's not a nice easy round number, so I need to calculate it. So I'm going to say my X is 158, my mu, the mean, is 178, and the standard deviation is 8. So I just plug that into my calculation, or my calculator. 158 minus 178 divided by 8. And when I put all that together, I'm going to get negative 2.5. So negative 2.5. And that is the Z-score. So the Z-score is approximately right in the middle. So that means that data point is right in the middle. What percent of the players weigh between 178 and 194? Well, thankfully, that is labeled. So 178 to 194. So we said earlier that this is half of 68, which is 34% here, and 13.5% here. Oops, let me erase it. So 13.5. So I can just add those two percentages together. So 13.4 or 34 and 13.5 is 47.5%. So we're measuring in percents here. So make sure you put the percent on the end. What's the probability that a player weighs at most 170? So here's the 170. And in order to weigh at most 170, that means you have to be below 170. So we know that this section, let's see, 34. So this is 13.5. And we know this is 2.35. And this is 0.15. So we're going to add those together. So 13.5 plus 2.35, plus 0.15. And when we add all those together, we're going to get 16%. And that's going to be our answer. Let's look at a couple more examples real quick. We have the price of a gallon of regular gasoline across the state is normally distributed with a mean of 2.05 and a standard deviation of 4. So 2.05, that's going to mean this is 2.09, 2.13, 2.17, and then 2.01, 1.97, and 1.93. So then it says, what percent of a gas station sell a gallon of regular gas for less than 197? So here's our 197. And we know this is 2.35 and this is 0.15. So we're just going to add those together. So 2.35 plus 0.15 is going to give us 2.5%. What percent of gas stations sell a gallon of regular gas for at least 217? Here's the 217, and we know that little section is 0.15, so 0.15%. And then what's the probability that a gas station sells a regular gallon of gas for less than $1.97 or more than $2.17? Well, less than $1.97 was 2.5, and more than $2.17 is 0.15. So that is going to give us 2.65%. So let's look at a couple of z-score calculations real quick. The main thing with these is you just need to be able to recognize the information that you're being given. So the mean number of total miles ran last week by each member on the track team was 4, with the standard deviation of 1.2. If Clay's z-score was 2.5, how many miles did he run? So I know that the mean is 4, and the standard deviation is 1.2, and we want to know, we have his z-score. So his z-score was 2.5. We're looking for how many miles he ran. That's going to be our x. So we're trying to figure out what x is. So we know that our formula is z equals x minus the mean divided by the standard deviation. So we're just going to plug those numbers in. So we've got 2.5 equals x minus 4 over 1.2. So I'll start by multiplying both sides by 1.2. Oops. 1.2. There we go. And when I do that, I'm going to get 3 equals x minus 4. And then I'm going to add 4 to both sides. And we're going to get x equals 7 miles. In the next one, it says a set of test scores is normally distributed with a standard deviation of 5. Riley scored an 83 with a z-score of negative 0.4. And what was the mean? So we're looking for the mean. So we're going to set that up again. So z equals x minus mu divided by sigma. So negative 0.4 equals 83 minus the mean divided by 5. So we'll start by multiplying both sides by 5. And when we do that, we're going to get negative 2 equals 83 minus mu. So then we subtract 83. And we get negative 85 equals negative mu. And when we divide both of those by negative 1, we're going to get mu is equal to 85. And that's going to be our answer. And then the last one is really actually not possible. So if you look at the heights of a group of trees is normally distributed with a mean of 14.3. Oops, 14.3. The z-score for a 10-foot tree is 1.9. Well, that's not really possible, because if you have your curve and the mean is 14.3, something that's only 10 is going to be over here, which would give it a negative z-score. So we're not going to do this one because it's not really possible. So give these a shot and try some practice. And if you have any questions, just let me know.